So good evening, everyone. So I am a student of Srinivasa Ramanujan Institute of Technology, Anand. So today my topic is about file system structure on the subject operating systems. So on the subject code is 23CSC402. So here I am Manju in front of you, and my roll number is 591 and CSC branch. So let us go through the topic. So what is file system? Basically, a file system manages how data is stored and retrieved. So, without a file system, data placed in a storage medium would be one large body of logged data with no way to tell where one piece of data stops and the next begins. So, it provides a way to separate the data into pieces and give each piece a name. So, basically, a file system defines a way to separate the data into pieces called a file system. So, file system structure overview. So, the file system structure resides on secondary storage. It is organized into layers. So, that is, there are 6 layers or 6 stages in the file system structure that are application, logical file system, file organization module, and basic file system input output control device. So these are the 6 phases or stages or steps in the file system structure. So uh, these are also defined as the 6 stages that are going to discuss about. So basic file system, access control module, logical file system, physical file system, device interface modules, device. So these are like types or stages of file system structure. So file attributes and operations. File attributes. So attributes are nothing but like names or type, location, size, protection, timestamps. These are types of attributes that are going to be that we are going to be treat as attributes. So operations. There are there are some types of operations that are create, write, read of the file, read to the file, write of the file, create a file, and reposition, delete, and truncate. These are the operations that are going to be performed on file systems. So metadata about files is stored in the file control block. FCB is denotes as file control block. So types of directory structures: single level, two level, tree structure, acyclic graph, and general graph. These are the types of directory structures. So let us discuss about single level. In the single level, one directory for all users. There is only one directory for all users. In that directory only, we need to create or write or read from files in that one directory only. So two levels. So separate directory for each users. So we can use either uh, one directory or two directories. It is a user choice. And tree structured, hierarchical. So these hierarchical means there are huge directories available. So acyclic graph, shared subdirectories of files. Shared subdirectories of files. So here in one directory there is a subdirectory, and in the subdirectory there is a again subdirectory. So these are acyclic graphs. General graph. Cyclic cycles allowed needs garbage collection. So file allocation techniques. Continuous allocation, linked allocation, so indexed allocation, hybrid methods. So there are 3 types of allocation techniques. Continuous allocation. These are fast and simple but can suffer from external fragmentation. So linked allocation. No fragmentation but slow access. So indexed allocation supports direct access, more complex. So hybrid methods are also used in modern systems. Access methods for files. Uh, there are different types of access methods for file systems: sequential allocation, direct allocation, so indexed allocation. Let us discuss about sequential allocation. So this is most common allocation, like file 1 and file 2 and so on, file n. These are the simple sequence allocation and linear allocation also. So um, linear access of the files, access data in order. So direct allocation, jump to specific locations. So if you want to locate some file in that specific location, so you can go to the direct allocation. So mm, suppose there are 10 files in one directory. So if you want the file 5, so then directly go to the file 5 instead of terminate one by one files, like. So indexed allocations, indexed access. Use an index to access data efficiently. So if there are 10 files in a directory, so treat file 1 as 0, indexed file 2 as indexed 1. So in this manner, we need to go to the file up to file 10, indexed 9. So, so chosen based on file, use case and allocation techniques. So mounting and file system integration. Mounting connects a file system to the OS operating systems directly. So requires permission and validation. Unmounting safely disconnects file systems, prevents data corruption and ensures security. Mounting and file system integration. So let us go to the topic file protection and security. So when we talk about file protection, there are some operations we do on files, right? So read, write, and execute, etc. So access rights, so there are three types: read, write, and execute. So mechanisms: access control lists, ACLs, and role-based access controls, RBAC. So encryption used for confidentiality, and voice handles authentication and authorization. So file protection and security. Um, so the operations that are which we are going to use, that will be more effective and efficient to the file. That is called file protection and security. So conclusion. Let us go in file. So finally, in conclusion, file systems ensure reliable data storage and access. Efficient efficiency, speed, and security are key goals. So, for example, file systems ensure reliable data storage and access. So, in files, we need to gather or read or write the accurate data in the file systems, only the accurate data. So, efficiency, speed, and security are key goals. Efficiency of the data is main goal, and examples are FAT, NTFS, and ext4, APFS, and ZFS. So, new trends: generalizing SSD optimization, cloud-based file systems. So these days, our cloud-based file systems are majorly used file system structures. So thank you.